our moderator of the session, Mr. Himanshu Rattan, partner KPMG in India. He specializes in government, including economic development, advisory, immigration, and also in company affairs. May I request him to please take center stage. Mr. Rahul Kapoor, our speaker, Joint Secretary, Ministry of Housing and Urban Affairs, Government of India. May I request you to please join all the panelists, please. He's managing the 100th Smart Cities mission in India. We in the morning also had Joint Secretary joining from Ministry, Mr. Kunal Kumar, and he had mentioned about the question being asked about the cities being how much development we want. He said we need to figure out our own kangaroos, how much development we want. So we thank him for joining us. He's been focusing, varied experience he brings in the field of infrastructure finance, focusing on PPP and with a background in economics. He's also a recipient of the National Award for Outstanding Performance in the Government. Our next panelist, the CEO of FIWARE Foundation, Mr. Ulrich Ahle, if I'm pronouncing your name correctly. He's a well-known expert in the broad field of IT, consulting, Industries 4.0, digitization, covering the entire spectrum from IT strategy, business models, organizational alignment, service delivery to operations, including corporate transactions and acquisition integrations. Next speaker, Dr. Inder Gopal, the CEO of the Indian Urban Data Exchange. He's also the research professor at IISc Bangalore, has had a distinguished research career in the area of computer networks with 20 patents and more than 70 technical publications to his credit. And we have Mr. Jacques Beltran, the Public Services Industry Vice President, Cities and Public Services, Dassault Systems. He's also been the diplomatic advisor to the French Minister of Transport and Infrastructure, and also has worked with Alstom in the energy and rail transportation sector in different capacities. So with that, handing over to our moderator.
Hello. Yeah. Good afternoon, everyone. Thank you for joining us for this session on the day one of the 8th Smart City Expo. My name is Himanshu. I'm a partner with KPMG, and it's my pleasure to be moderating this session on accelerating future smart cities using data and digitization. As part of the session, as was briefed earlier, also we'll be talking about smart data policies and how data and digitization can shape the future of our smart cities. And as as we can see, we have a very, very distinguished panel with which we'll be discussing these matters. I think with the rapid digitization and penetration of technologies, there's a huge amount of data that's been generated, and data is the new oil. The whole idea is that that data is going to be useful if we leverage it in the right way, and that's a daunting task. And therefore, with that, I just wanted to begin the conversation and discussion with Mr. Rahul. You've been driving the implementation of smart cities across the country today, and as we know, data is at the heart of all the operations of a city across different domains, whether it's health, whether it's safety, whether it's traffic, and therefore we wanted to understand how cities have leveraged smart data policies and what is the kind of impact that they've been able to generate as far as improving quality of life is concerned.
A very good afternoon, everyone, and thank you so much, Himanshu. So of course, it did not start off as a journey of data. And when we talk about the Smart Cities mission, when it was announced in 2015, the first dialogue was around implementation of technology to solve the common services and service delivery issues that the cities were facing. But slowly and slowly you realized that with all the technology implementation that was happening, a lot of data was also getting generated. And you talk about data being the new oil, but that is not always the case, because definitely oil has a lot of value. But the way the data is stored in most of the organizations today, it is more like gold. So in terms of gold does not really flow. So how do you get that data to flow from one organization to another? That was definitely one of the challenge. How do you get the people to understand the world of data and technology? That was another issue that we were all dealing with, because with all the technology implementation that was happening, so much millions of dollars and of money that was getting invested in the cities, and certainly you had very, very little capacity to understand what to do with the data that comes out of it. With regard to the processes in handling of data, that was again a big, big concern, because who would basically approve the data collection processes, who would approve the data exchange protocols. All those were definitely an issue at the city level. And then again, every city, every state was trying to build its own data platform. So it was very little of peer-to-peer learning that was really taking place. We were all trying to invent the wheel at our own levels, so not really talking to each other. And that's why there was a need to change this. And how this movement started off was with the data smart city strategy that came out in 2019. And we basically talked about getting the right kind of people in the city ecosystem to understand and talk the world of data. So you had city data officers getting appointed, data champions being identified in various government departments and non-government departments, starting to build alliances with these people and building processes of data exchange and data transfer that started developing over the years. And yes, it has been a long journey. Like I said, it did not really start off with data. Same way the maturity has evolved over the years. So if I look at it, how we started off by talking about open data in the first place when we started the mission, and then on moved on to things like data exchange, and today we are even talking about building a data marketplace where the value of data can be basically captured. So this evolutionary journey has led to, let us say, all the 100 smart cities today having city data officers, many of them having their own city data policy, which talks about issues with regard to the institutional mechanism to basically deal with data, getting proper budgets allocated for data and technology related work, getting the right kind of people in the ecosystem who work on these lines, getting domain expertise, be it geospatial expertise that is required, the AI, ML, the emerging technology expertise that is required in cities. So this has been a wonderful journey for all of us. And if you're talking about the impact, well, it led to a lot of innovation also taking place. So it started off with maybe a off-the-shelf product that was getting deployed in cities, but then it was very soon realized that the local context has to be addressed. And that's where the innovative mechanism was built into this program. And somewhere along the lines, I am sure Dr. Inder Gopal will be talking about some of these innovations, be it in city surveillance, be it in water management, be it in traffic management, how you do bus route optimization in cities, how do you increase your revenues from property tax or other kind of tax revenues, how do you use basically data to improve your overall city governance, reduce costs. I think those have been the wonderful use cases that have been developed, documented, and the need is now to scale it up beyond these 100 cities.
Yeah, thank you, Rahul, for that. Taking us through the journey, and as you mentioned, I think you compared it to gold, and I'm sure gold in India we look at gold as an investment option, and I'm sure data is an equally sound investment option today as far as smart cities are concerned, and also the kind of impact that's we've been able to generate across these 100 smart cities. Next, I would want to move to Mr. Ulrich, and you've been an industry stalwart, and you have experience across multiple industry sectors focusing on IT, but just wanted to understand, you're into open source technologies, and while we understand a lot of benefits that come out of these open source technologies, but there are number of risks also that are associated with it. How do we kind of mitigate those risks, especially in a government kind of a scenario?
You're right. We are talking about closed source or commercial software on the one side and open source software on the other hand. First, let me differentiate between open data on the one side, and then the question, is it implemented using open source or closed source solutions? I think we all agree on the benefits of open standards, of standard APIs, standard data models, which on the one side enable interoperability between different cities, but also between different players within a city and a given environment, but also enabling the replicability of solutions from one end user, in this case here being a city, to another city, that not every solution is built up again and that it is made easier to replicate. Then talking about risks of open source. One risk is clearly that you need to have a look at the ecosystem behind an open source software. Open source brings its value when it is created in a large ecosystem, not only supported by one company who has decided to put their software open source and may decide the next day to put it back and close it again. So it is important that there is a vibrant ecosystem of different players, best even international players around it, and that is the basis for the maintenance, for the further development of this open source technology. And I've been working in different verticals, in different industries, and we have complete different scenarios. For example, in the manufacturing industry, where we are talking about Industry 4.0, there we really need to convince the end users that it is possible to support mission-critical processes based on open source technology. Because there is a fairy tale that open source wouldn't be safe and secure, but this is definitely not true. On the other hand, in a lot of countries in the public area and in the smart city area, open source is even requested. Looking at open source communities, as I mentioned before, with a broad range, but here one principle in a lot of countries is applied called public money, public code. So a lot of these activities are being started using public funding, and then the results of this work should be publicly made available. And here, open source is the right instrument. Maybe a last point regarding possible risks is that also when talking about open source software, you need to select the right open source license. Yeah, that these licenses, these regulations allow the usage and also the contribution, but also request some contributions from the end users, because an open source community is living from a give and take, clearly a give and take, and not only having people who are taking, but we need in open source communities, like we have it in the FIWARE ecosystem. We are talking in the meantime about more than 8,000 developers worldwide who are contributing, maintaining the software components we are providing. And as I said, the main risk to mitigate is to have a clear ecosystem behind such an open source technology.
Thank you so much, Ulrich. And I think one for breaking down the myths that open source software is not really for mission critical scenarios, and also highlighting that a number of these risks can be mitigated by having an open ecosystem with international players also contributing. Thank you so much for that. Next, I'll move to Dr. Inder Gopal, who is the CEO of India Urban Data Exchange. The India Urban Data Exchange is a transformative initiative of the Government of India to provide a data exchange platform for Indian cities. We just wanted to understand the journey of this entire platform and how different cities are leveraging. A few use cases would also be helpful.
We started working, say, about 4 or 5 years ago with an Indian Institute of Science on some concepts and ideas on how to share data. And it was largely an academic exercise, interesting research work. And then we were fortunate enough to meet with Mr. Kunal Kumar and Mr. Rahul Kapoor. And they kind of explained to us, hey, look, we have exactly the problems that you guys are working on. We have these problems in the smart city context. In particular, we have a lot of data in smart cities, right? You know, sensors, cameras, legacy data from databases, records, public records. We have all kinds of data. Right? But it's very hard to actually get people to use this data for a few reasons. One is nobody actually knows what data there is, right? So the data is very often created in what are called silos. So, for example, you may have the police department, that has put in some sensors and maybe cameras, and maybe the fire department could have used that, but they don't even know this data exists, right? So there's just a lack of understanding of what's available, what resources are available. The second reason is very often there is some access management that's required with this data. I mean, you can publish the data and make it open data, but not every data is open data, right? You want to share the data, but you want to share it in a controlled fashion, right? So you don't want to just put it up there, anyone can download it. You want to make it available, but you want to make sure that the people who get access to it are actually the people that you authorize access. That way there's a lot more data that can be made available. So you need techniques which allow you to do that. And then the third reason why it's extremely hard was also because the way data is represented was just inconsistent. There were no standards, right? So you may have air quality monitors from different vendors representing the same information in very different ways, right? One is saying, sulfur dioxide and using, a certain set of units to measure sulfur dioxide. One is saying SO2 and using completely different units to measure. So how do you make sure that there's a common understanding of what the data represents, right? The data models are very different. And then finally, there's issues with data quality, all kinds of things like that. So we thought a lot about that. We said, oh yeah, these are very interesting problems. And we, over a period of time, developed something that we call a data exchange, right? Looking at best of breed around the world. So we looked a lot at what Ulrich and his team have done in FIWARE. We looked at other projects around the world. And we created this thing called the India Urban Data Exchange, which is a software platform that now is actually deployed in 35 cities. It's a production system, it's working. You can go to iudx.org.in and you can actually see, all the cities that are there, all the data that's available. So if the data is open, you can actually get access to the data. If the data is not open, you can apply to get access to the data. And so over a period of time, what we did is we developed the technology, we deployed it, and we have now a mechanism in 35 cities to be able to solve many of the original problems that Rahul and Kunal, suggested to us, 4 years ago. And what we have done is actually taken the basic platform. We have now onboarded data from, as I said, 35 cities. And we have created use cases. Because just having the data there is not that useful, right? Just putting the data, what good does that do anyone? So the thing is, can you use the data for something useful? And our goal has been in every city that we are deployed to really create at least one use case, working with partners, and then show the way for others to come in and build other use cases by themselves. So for example, in Varanasi, we have come up with a solid waste management optimization case, working with a partner. And what we have is data that's coming in from a whole bunch of different instrumentation of solid waste. So the garbage cans, the garbage bins have instrumentation. The trucks have instrumentation, even some of the push carts that go in the back alleys in Varanasi, they have instrumentation. So you know where they are. And what you can do is by taking all that information in real time, you can optimize the way garbage gets picked up, right? So rather than having a fixed pattern of picking up garbage every day, what you can do is have a dynamic pattern that every day, sees where garbage is being piled up, If there's some festival, say in one part of the city, maybe you need more garbage pickup in that area. And so by optimizing the movement of the garbage trucks in a very dynamic fashion, you can actually reduce the overall cost by 30%, which is a significant benefit to the city. So that's one example, right? We have other examples in Vadodara, where we have created a green corridor for ambulance movement and for emergency vehicle movement. And that has actually helped save lives, right? Something like, I heard a statistic, 30% of the people who are picked up by an ambulance in India die before they reach the hospital, right? I mean, if you think about that, that's just a horrendous statistic, right? 30% of people don't make it to the hospital. And, a whole bunch of reasons for that, some of them related to traffic conditions. And if we can somehow alleviate that a little bit, as we have tried to do in Vadodara, it's a big help. In Agartala, we have optimized the movement of traffic using automation of traffic lights and getting a lot of statistics and data that helps that. In Chennai, we are doing flood management, right, prediction. Right? In Bangalore, we're trying to do multimodal transport, right? Mixing mixing data from transit system with data from the last mile providers who do private vehicles to travel the last mile, and then trying to put them together to create end-to-end journey optimization. So there's a whole series of use cases like this, which we have done in, as I said, 35 cities. And I think it's starting to show that data it's not just sitting there in some database, it actually can be taken and used. If you can open it up, you can make it available, you can make it accessible, understandable. There's a lot that you can do with data.
Fantastic, Dr. Inder. I think really, what some of the challenges that you highlighted at the start of your conversation, it must have been a daunting task. It's not easy to kind of make sense of data coming out of 35 different cities in different standards and different way it's stored. And also some of the case examples that you took, whether it was Vadodara, Varanasi, Agartala, it only shows and gives confidence that this is only a start. We have a significant amount of more that can be achieved with it. So I think thank you so much for that, Dr. Inder. Next, let me move to Jacques. And Jacques, comes from Dassault Systems. Dassault has a number of 3D and VR technologies which you've already deployed in a number of cities and helping them in various use cases. We just wanted to understand how 3D VR kind of solutions that you have been leveraged elsewhere, and how can they be kind of customized for India as well?
Well, good afternoon, everyone, and thank you very much for inviting me. So yes, indeed, what our company, Dassault System, has been doing for the past 40 years is, starting in the manufacturing industry, is designing what we call virtual twin. A virtual twin is simply I would say a 100% accurate replica of the real world. It's science-based. So it has happened a long time ago in the manufacturing industry. Today, 9 aircraft out of 10 have actually been designed using our technology, virtual twin technology. The same in the automotive industry, for example. But that's now beginning to apply to cities. If I carry on this analogy, in the aeronautic sector today, and for the past years, of course you don't do crash tests. You don't crash aircraft to see if they fly or what are the conditions for them to fly. You test that virtually, and you actually certify, validate aircraft using virtual twin technology. Well, the idea is to apply this to cities and to public policies implementation. So in concrete words, what does it mean? Virtual twin technology is being used in many cities, of course, for urban transformation. Before you plan transformation of a neighborhood or introducing a new infrastructure, you can design and test those changes in the virtual world before you actually apply them to the real world. But the good thing is that these cities' virtual twins that are very useful, I would say, in times of peace, They are also extremely useful when crisis hits. Let me give you two examples. First one, we are currently working in Japan with the city of Kyoto. Kyoto is facing regularly flooding events, and they want to address those flooding events in a much better way than they have been doing so far. So what they asked us was to build a 3D twin, the 3D model of a city, and to play the simulation of a flooding event in one neighborhood of Kyoto. And now they're using that simulation to plan escape routes for the population. So they have developed a mobile app that citizens of Kyoto have on their mobile phone. And when there's a flooding risk, they receive an alert, they are geo-localized, and the app tells them what is the best escape route based on the flooding scenario and also on the traffic management situation. That's a concrete example of how you can use virtual twin technology in crisis times. A second one that I think is really interesting is a couple of months ago, we started working for the Ukrainian government to help them in their reconstruction efforts. We leveraged our platform, our digital platform called the 3D Experience Platform, to capture data through satellite imagery and automatic change detection. Data about the destructions caused by the war. And that data is being capitalized, as you say, all this siloed data is being brought together into one single place. Then our software is used to prioritize the reconstruction effort. And then, although the war is still waging, designers, urban planners can start working on 3D model, 3D design and 3D simulation solutions to start thinking for the future of their city and hopefully build back better. So these are two concrete examples of how this virtual twin technology can be leveraged in the context of city development.
Fantastic. Thanks, Jack. I think the Ukrainian government work as well as the Kyoto disaster management example that you gave are equally important for India as well. And I think we'll be happy to see how some of your solutions can be localized for the problems we are trying to address in our Indian cities. So thanks for that. Next, let's come back to Rahul again. And we've been the smart city mission focused on 100 smart cities, and over a period of last 7 to 8 years, different cities have reached different levels of maturity, also in terms of data now. How do we kind of make sure that the work, for example, being done in Varanasi or Agartala, how some of these cities can actually become lighthouses for other cities to replicate the work that's being done? So how does the government plan to do that?
So when you're talking about scale up, and when you look at the scale that we need to look at, so from 100 cities, we have to think about 4,800. And with 4,800, it comes with its myriad kind of challenges with regard to spatial differences, with regard to the level of financial stability and strength of many of these cities, the resources that are available. See, Smart Cities mission was a central government funded mission. It was $26 billion that was getting invested in cities. But when you're talking about scale up to 4,800, you will definitely have to think of a much more smarter way of doing this. And thankfully, certain learnings have come about in this 7 or 8 years of journey that we have gone through. So one is, of course, moving from a mission, which was the Smart Cities mission, to a movement. And then when you're looking at the city level, you have to intervene in two levels. One is, of course, the technology. This comes over and above the physical layer, which is again missing in many of the cities. But then you have to have a technology layer on top of that, starting with maybe some bigger size cities that you can think of. And on top of that technology layer, then you also need to have a data layer and the application layer. So that is another support that would be required. And if you look at it, the institutional mechanism that needs to be put in place in the state governments, in the urban local body level, that also has to be thought about. So you have to have an institutional mechanism that looks at program implementation at the state level, at the city level. A bit of overall coordination that would be required. That has been a learning of the smart cities, because 100 cities, each one trying to do its own. But when you're looking at it, moving on to 4,800, you'll have to basically aggregate the amount of data that is coming out and probably do better insight and analytics work on top of that data. So that kind of a mechanism would be required at the institutional level, at the states, at the cities level. So what is operational data and what is the analytical skill set that would be required at the states? So that is something that one needs to think of. So I think this is how we need to work on. So address the people issue, which is again a big concern, because in many of the cities you don't even have a person who can understand this world of technology and data. So then that means it would require seeding in people in cities, so that when the national level government, where the capacity is already existing, the state level government, which is maybe at a higher level of maturity as compared to these cities, when they reach out, they do manage to get a response from that side. So maybe this is the overall strategy that we need to look at when you're talking about scale up.
Absolutely. No, I think, what you mentioned, the mission to movement campaign will need to begin. And also, from what I hear is, it might be easier to make some of these cities where a good work, as lighthouses or, as case studies for other cities to look at. The real challenge is the capacity on the ground. When we're talking about 4,800 cities being covered, the capacity on ground needs to be augmented to be able to deliver on some of these aspirations that we have. Next, Ulrich, we're talking about future smart cities, right? And there is certain amount of digitization that has already happened. There are real-time data which is being made available and use cases being built around that. But when we are really looking at futuristic smart cities, we also need to talk about predictive intelligence. And that's where, technologies like AI, machine learning, IoT to what extent would also come and play a part. What do you think the role of new technologies can be as far as predictive intelligence is concerned?
Yeah, this is a very important thing, because just collecting data on a platform doesn't create any real value. The real value comes out of smart solutions, using this data, enhancing data by additional information coming from social media, coming from weather services, coming from satellite data, and then using artificial intelligence, using big data analytics to create smart solutions for the benefit of the citizens living in the cities, and not only in the cities, but also in the rural areas. We are talking always about smart cities, but a lot of people are living in the rural areas, in villages, and we need to close the digital divide, because also these people have the right to use smart solutions based on data. And here artificial intelligence is and machine learning is a very important topic. I think, Jacques, you mentioned water management systems, flood warning systems. I'm living in a little village in Germany where we are actually creating such a solution based on sensor data coming from the river level, the amount of rain, the ground level water, the soil moisture, and so on, but enhanced by rain radar, by weather forecast, by what we call hyper-local citizen data. So when I have a rain situation, is videos taken by the citizens, all put together, and then using artificial intelligence to create a pre-warning system. To have an advanced warning message of at least 10 to 15 minutes before really the water is standing in front of your door. And this is something which is creating value for the citizens, and that's very important in all our digitization activities, to create value to the end users and to do it quite fast and soon when starting a program. It doesn't make sense to start a program and have theoretical approaches for 3 years without really bringing value to the end users. And this is true not only in smart cities but also in other domains. So nothing really new, but it needs to be adopted.
Absolutely, and I think what I understand is one is obviously the predictive kind of intelligence is going to help improve the general quality of life of citizens, but it also can help save lives. Whether we are talking about the ambulance example that was given earlier or the water level example, I think it really can help save lives.
Yeah, and maybe one more example from my little village. We are working on a solution to operate autonomously flying drones to support the fire brigade. So as soon as an alarm is started, the drone is starting, flying to the GPS geolocation, which is given. And once the fire brigade is in the cars, they have a tablet and can see what do they expect at the place where they are. So if they are, do they need to activate other forces? For example, an accident on the highway, do they really get there, or do they need to choose another way to get there and to have access there earlier? And this is a part of saving lives.
Absolutely, very, very relevant. Next, let me move to Dr. Inder. And you've been working with 35 cities, interacting at least with 35 of them. And I think you of all of us would know that a vanilla approach would not work, because the problems are very localized problems, and therefore the solutions also have to be very, very localized. And when we are talking about scaling this up to 4,800 cities across the country, how do you think we should address this? Because a one size fits all approach would not work.
No, that's very much true. I mean, a one size approach will not work because every city has its own unique problems. I don't know, Chennai has flooding, Bangalore has traffic. I mean, each city has, Delhi has pollution. I mean, each city has its own unique issues, and obviously also the data that's coming within each city is different. Maybe the interests of the citizens very often are different. You have cities like Agra, which are heavily tourist oriented. You have other cities which are perhaps much smaller and maybe don't have that kind of focus. So there's all kinds of different interests and different environments that. I can't even hear myself, so I hesitate to ask whether you can hear me. Should we wait a little bit?
I wish we could somehow predict that happening as part of our session.
Yeah, I think that would have been really fun. But, so I think you're absolutely right. I mean, every city is unique. But on the other hand, the only way in which you're going to scale, as Rahul said, to 4,800 cities, especially given the paucity of skills, right? I mean, it's one thing in a city like Bangalore or Delhi, or you have a lot of smart people who can design systems, who can kind of tailor the system to meet the needs of the city. But in smaller cities, especially as you go lower and lower down, the population scale, it's very hard to get these skills. Very hard to get people to understand, what sensors to put, where do you put it? These are extremely hard things. I think you've got to go towards standard solutions. There is an importance. I mean, there is a role to be played for customization and tailoring of solutions, but there's also a role for standardization, right? And having standard interfaces, standard platforms, which can be customized as appropriate, but right out of the box, they should be, giving value, right? So you don't necessarily need huge amount of skill within the city in order to deploy a solution. And so that's part of what we have been working on, which is taking a lot of the learning that we've got over these 35 cities and saying what is common, right? What is the kernel of commonality, right? That we can sort of package and almost create something that we would think of as a city operating system, right? That can be like if you like, the Linux of cities, right? That you can go deploy everywhere. But that doesn't mean that you're restricted to those functions. You can then add on top of that and create additional things and to customize as on the basis of what the city needs. So that's sort of some of the thoughts in terms of scaling.
Absolutely. So what we're saying is almost a city ERP in a way, right?
Yes, a city ERP.
A city
right.
ERP wherein perhaps a 80-20 rule, if that applies, maybe 80% of the solutions can be common and maybe 20% of customization in every city.
Yes, I think that's actually probably a very good number, right? I think a lot of it is and that's probably true of almost anything that you...
Almost anything, absolutely, yes. Next, Jacques, while we are on new age and cutting edge technologies, a lot of problem, in India across cities is also that there is no room for any greenfield implementation and a greenfield kind of an upgrade. So how do we leverage some of the technologies, at least especially the new age technologies, to do a brownfield kind of an implementation where starting from scratch may not work, and maybe any examples that you can share around that?
Yeah, I think that's an important question, and thank you for raising it, because digital twin technology and smart cities are often associated with this idea of brand new cities, of the green fields that you're mentioning. I don't know, like for example, the new capital city in Indonesia. Everybody's going there and offering smart city solutions because it's a green field. But I think the power of virtual twin technology is that I would say it mostly applies to brownfield, to existing cities. That's where you can actually leverage that technology the most. Thinking, for example, Singapore, today the city of Singapore is using virtual twin technology to start planning for the impact of rising sea levels. The sea is rising, that's going to impact existing infrastructure, existing city. How can we plan for that? Or fighting against heat islands. All cities have heat island problems. How can you plan by introducing new vegetation? These are things you can do with virtual twin technology. But I'll give you one example that we've been working on recently, which I think is interesting in that respect. For those of you who visited Paris, there's a ring road around Paris, and as you maybe know, Paris will be welcoming the Olympic Games in 2024. And the city of Paris has decided, in view of that event and the number of people that are going to come visit the city, they've decided that one lane of the ring road would be reserved for car sharing, car pooling, to facilitate traffic there. Well, that decision is creating a huge political debate. Because some are in favor and others are saying it's going to create chaos. Just reserving one of the 4 lanes for carpooling is going to create chaos in the 3 other lanes. And then people are imagining what's going to happen in terms of associated noise or associated pollution emissions from those cars, from that traffic. Well, what we did was actually to collect open accessible data to build a traffic model of this ring road and to exactly play that scenario. And we were able, thanks to that, to determine the tipping point, the point at the number of passengers per car on the ring road, so the car sharing ratio that is optimal. The level, the number of passengers at which the decision becomes a useful decision. So for example, today there are 1.1 passengers per car on that Paris ring road. If you implement that decision, it is indeed going to create chaos. But if through various incentives, the municipality succeeds in raising that car sharing ratio up to 1.3 passengers per car, then it becomes a very efficient measure. What I'm saying here is, and of course after the traffic, we are able to simulate the impact in terms of noise or of CO2 emissions coming out from cars and the way those emissions will actually disperse in the area around the ring road. So what I'm saying here is that this virtual twin technology and 3D twin models, they are also very useful, not only to help public authorities make the right decisions from start, but they're also very useful for local politicians, local public authorities to communicate the decision and to build consensus. if you make a decision without actually showing that it is an objective decision, so science-based decision, it creates debate. But if you turn the invisible visible, basically, pollution is invisible most of the time. I mean the emissions or the noise is something that you cannot anticipate unless in a virtual twin, in a digital twin, you play those scenarios on a science-based approach. And then your local decision becomes an objective decision. There can still be a debate, but at least the debate is around science-based approach and not just speeches or intentions. So definitely, I think that this idea of virtual twin technology for existing infrastructure, how you can play scenarios, what-if scenarios on the different changing usage of an existing infrastructure is indeed an extremely relevant use case of virtual twin technology. Thank you.
Very, very interesting, Jacques, and very powerful as well. And I think a number of cities in India, like Mumbai, etc., where we don't have room for infrastructure growth, can benefit from technologies like this. Did you want to comment, Dr. Inder, or do you want to make a point? No. Okay. Oh, okay. I was just. But I think we have 5 more minutes, and we'll open it up for a brief question and answer. So if you have any questions, maybe we can have it now. Can we have mic being provided? If you can stand up, introduce yourself and then talk about the question.
Yeah, I'm Balinder Singh Sethi. I'm President Vahandit. My question is for Mr. Rahul or Inder. How you are planning to, it is a two-pronged question, how you are planning to ensure the continuity of the data technically as well as financially in these smart cities, considering there will be obsolescence of technology, there will be end-of-life products, and there is a government system of renewing contracts after every 5 years. And how financially, because historically urban local bodies have been very financially stretched. The initial impact of 100 smart cities was funded by Central. What is the plan for further, and how you are planning to upgrade it to 4,800 cities?
So you're absolutely right. There has to be a transitioning plan, because as the smart cities mission will come to an end, every mission has a defined time period, and the initial thought was that this will be taken over by the state governments if they see value from it. So what the smart cities mission did over the last few months, they worked on 2 strategies. One is the operational SOPs, the standard operating procedures that smart cities need to have for their command and control centers, for their data centers, and how the data will flow. And the second was building a business plan for all the 100 smart cities. So wherein are you going to get the revenue to make the command and control centers sustainable? So with regard to, let us say, if you're providing services to the police department, that leads to a cost saving by way of, let us say, reduced deployment of manpower or more focused deployment of manpower, or if it leads to cost saving for the water supply department. So that becomes a business case, and that is what the cities are working on right now. So that is going to be part of the strategy of transitioning and handholding. And of course, for certain cities, when you're talking about 4,800, like I mentioned, they're all at different level of maturities. Many of the cities don't even have a physical layer today if you really look at it. I mean, there is some physical layer, but then having that layer on top of that, the technology layer. So it will have to be done in a phased manner, and it's going to take time, but then you have to have a roadmap for it. So that's what I think the government would be working on right now.
Yeah, I'm Sunil Kumar Shinde from Mumbai. We know that data is gold now. And nowadays, actually, the metro cities, like say Mumbai, is nothing but we can say data-driven cities. Those cities are driving a lot of data now. And how do you think about to say save data in template wise, so that the tier 2 cities like Solapur, maybe in Aurangabad or something, whatever the cities can able to utilize whenever they want, because you know that the data is a huge amount of data is getting stored, and if it is accessible enough, then that can be utilized at the earliest.
Dr. Inder, do you want to kind of comment on that?
So I didn't catch all the question, but I think it was about tier 2 cities, right, mostly, and how we are going to extend to tier 2 cities. So if you look at the 100 smart cities that have been chosen, there's a whole selection of cities. It's not just the mega cities. It's all kinds of cities, ranging from extremely large mega cities to very small cities, and which you might consider tier 2 or whatever. I mean, so we have what works for smaller cities, and I think a lot of it is what I was saying before, which is what we're trying to do is package that learning, right? So you don't want to have every city go and learn the same things again and again, right? Once, say Chandigarh has learned how to do smart parking, right? That same lesson you should be able to take and move to Gopal, right? You shouldn't have to learn the same thing again, right? So that transportability, right? That the ability to take an application that's developed in one city, move it very quickly to another city, all that requires standardization, right? That is kind of a fundamental pillar upon which a lot of this has to run. It requires standardization of interfaces, standardization of the way data is represented, and if you have, and also in some cases standardization of the software itself, right? And if you can do that, what you find is you can scale these things, right? Because the learning is not just in silos. Learning that is in one city can then be moved to another city, can be moved to another city. Application vendors that have been successful in one city can very quickly move to another city and take the same applications they've developed and then apply them, to another city and give them the benefit of the knowledge. So breaking these silos, opening interfaces, letting data becoming available, transferring learning from one city to another. These are the key things in order to, move from, the 100 smart cities to the 4,800 that we would like to get to.
Thank you so much. I think that's all we have time for today, but what a great session it's been. I think I enjoyed hearing all the panelists, and I'm sure the audience kind of had multiple takeaways as well. Thank you so much. Thank you, everyone.
Thank you, and may I request Sachin to kindly present the mementos, expressing our thanks to our speakers as they shared with us about data, analyzing of data, generating smart city solutions, towards predictive analysis, towards how this the technologies of twin technologies, the virtual twin technologies being used for simulation, which can help in disaster management, disaster risk reduction. So thank you to each one of them.